Hello everyone, this is Zafra, or you can call me Raza, and welcome back to my YouTube channel, And today we are actually going to learn another lead code problem and solve it. And that problem is 392 is subsequence. So you can call it is subsequence, or you can call it you can also call it like validate subsequence or validate sequence, stuff like that. So the problem is pretty simple. It is written here as well. So I'm going to read through it once. Given two strings S and T, return true if S is a subsequence of T or false otherwise. And a subsequence of a string is a new string that is formed from the original string by deleting some, can be none of the characters without disturbing the relative positions of the remaining characters. That is a subsequence of A, B, C, D, E, while A, E, C is not. So how would this make it valid, but this not? And you can pretty much look at it like this, because we have a string which is A, B, C, D, E, right? And we have another string which is A, C, E. A pretty simple way of doing this is to actually use two pointers. So we can say that we use two pointers. One is a pointer for A. So a pointer A, which is for this string, and a pointer B, which is for this string. And now we can show it like this. So when we are at this position, this is pointer 1 and this is pointer 2. First of all, we are going to compare the both pointers and see if this is a matching scenario, and it does match. So we are going to eliminate A, and we are going to eliminate A, and we are going to move both the pointers ahead. So let me just move these pointers ahead, and well, we are going to see if C matches B, and it doesn't. So we're going to move the pointer 1 ahead, because we're not going to move this because we did not find it, but we will move this regardless. So this pointer is actually going to keep moving. It will not actually stop at all. So pointer 1 actually keeps moving in all iterations, and it never stops. Again, we are going to match if C is found here. If the both pointers values matches, then we are going to move both of the pointers ahead, and we are going to cut out C because we found C, and we'll move both the pointers ahead. Now this is not going to match, so we can move only this pointer ahead, and we can keep the pointer 2 at the same position. And at this iteration, both E's matches, and we can actually cut this out, and then we can move both the pointers ahead again. So now our pointer is actually at this position for P1 and at this position for P2. So we have reached the end of a string here and end of a string here, and then we can actually stop the loop here. So whatever the loop is, it is much better to use a while loop here. So we'll use a while loop here, and we can stop based on these conditions. Also, the time complexity for this algorithm is O of n, and the space complexity is actually constant. So O of 1 for the space complexity. And that was all. And we can actually go into the code now. We are going to make two pointers, both starting from 0 index. We are going to assume that pointer A represents the subsequence and pointer B represents the actual complete sequence of strings. Which is in this case A, B, C, D, E, and the subsequence is A, C, E. Then we're going to create a while loop. That while loop will have condition that if pointer A is less than the s dot length, so the length of this subsequence, and pointer B is also less than the length of D string, then we can keep continuing the loop. And in that loop, we're going to have a simple if condition where we will be matching as pointer A, the value at this location, with the value at pointer B's location of T string. If those both matches, in our case, it would be at first iteration, it would be A matching with A. And when that matches, we can actually increment the pointer A, which is the pointer A in the A's string. So this is the A's string. We're going to increment the pointer A, and we're going to get to this position. And for the pointer B, we are actually keep going to increment it. We will never stop incrementing the pointer B. And then once we are done with this loop, once we are passed the pointer A length and also passed the pointer B's length, then we can stop the loop and go into our another if condition, which is pretty simple. You can actually do it with a ternary operation as well, but I did not do that because it makes it more clear this way. What we are doing here is simple, is that we are matching the pointer A value with the s.length value. So this is just to make sure that we have actually exhausted our subsequence string and that we have found every element that we were looking for. So for the first time, it's going to be 0, then it's going to be 1, then it's going to be 2, and at the end, the value of pointer A would be 3. So when it's at 3, we know that we've actually gone past our E and we have found every item. So that's why we can actually return true here, and otherwise we can return false. So that was all, guys. Hopefully you got this explanation, and make sure to like the video and subscribe, and I'll see you guys next time. Bye bye, take care.